Look up at the night sky, and there it is. The moon, Earth's mysterious partner in space, always present, always shifting its shape. But what truly is this gleaming companion that follows us through the darkness? Let's journey into the science of Earth's one and only natural satellite. The moon's story began in cosmic violence around 4.5 billion years ago. Scientists believe it was born from a cataclysmic event known as the Giant Timpact Hypothesis. In this scenario, a young molten Earth was struck by a rogue, Mars-sized protoplanet named Vey. This colossal collision was so powerful that it vaporized parts of both bodies, launching a massive cloud of superheated rock and debris into orbit around our planet. Over time, gravity did its work, pulling the swirling material together, which eventually cooled and coalesced to form the spherical body we now recognize as the moon. When you gaze at the moon, you're looking at a surface made of materials quite similar to what's beneath your own feet. Its composition is primarily rock and fine, powdery dust. This surface layer, a blanket of fine gray soil and pulverized rock fragments, is called regolith. It's been created over billions of years by the constant bombardment of micrometeorites. Beneath this dusty exterior lies a solid crust, mantle, and core made largely of silicate minerals, the same family of rock-forming minerals that make up the vast majority of Earth's crust. This shared geology is a key piece of evidence supporting the giant Timpact origin theory, suggesting the moon is, in a way, a child of the Earth. However, despite these similarities in composition, the moon is a starkly different world. It is a silent, static place, devoid of the dynamic processes that define our planet. The moon has virtually no atmosphere to speak of. Without a blanket of air, there is no weather, no wind to sculpt its surface, no clouds to cast shadows, and no rain to carve rivers. This also means there is no protection from the harshness of space, while temperatures swing wildly from scorching highs of over 120 degrees Celsius, 250 degrees Fahrenheit in direct sunlight, to frigid lows of minus 173 degrees Celsius, minus 280 degrees Fahrenheit in the darkness. Furthermore, without an atmosphere to trap heat or pressure to keep it from boiling away, there is no liquid water on its surface. The moon is a barren, silent desert preserved in time. Yet, for all its distance and desolation, the moon exerts a powerful and constant influence over our world. Its most visible effect is the ceaseless rhythm of the tides. The moon's gravitational pull is not uniform across our planet. It pulls more strongly on the side of Earth facing it, and more weakly on the side facing away. This gravitational difference creates a bulge in our oceans on both the near and far sides of the planet. As Earth rotates beneath these bulges, coastal areas experience 2 high tides and 2 low tides approximately every 24 hours. This gravitational dance between Earth and the moon is a fundamental force, shaping coastlines and marine ecosystems. The moon's gravitational gift to Earth extends far beyond the oceans. It acts as a crucial anchor, stabilizing our planet's rotation. Earth spins on an axis that is tilted by about 23.5 degrees relative to its orbit around the sun. This tilt is what gives us our seasons. Without the moon's steady gravitational tug, this axial tilt would be far more erratic. Our planet would wobble dramatically over long periods, swinging between extreme angles. Such chaotic shifts would lead to catastrophic climate swings, with seasons becoming unpredictable and severe. It's possible that without the moon's stabilizing presence, the relatively stable climate that allowed complex life to evolve and thrive might never have existed. Imagine a world without the moon. The nights would be profoundly darker, lit only by the distant stars. Stargazing would be spectacular, but the familiar, comforting glow of moonlight would be gone.
Ow.
Our days would also be different. The gravitational interaction that causes tides also creates a slight drag on Earth's rotation. It's gradually slowing it down. Without the moon, this braking effect would vanish, and our planet would spin much faster. A day might last only 6 to 8 hours. This would have dramatic consequences for our weather, creating fiercer winds and more extreme storms. Life, if it existed, would have had to adapt to a much more rapid cycle of day and night. For as long as our species has looked up, the moon has been a source of wonder and inspiration. It has served as a celestial clock for ancient civilizations, a guiding light for nighttime travelers, and a canvas for our greatest myths and legends. Cultures across the globe have woven stories about the man in the moon. the rabbit-pounding Mochi, or the great goddesses who rule the night. It has been a symbol of romance, a muse for poets and artists, and a driver of scientific curiosity, ultimately calling to us until we finally set foot upon its dusty surface. From ancient folklore to modern science, humans have always looked to the moon for guidance, myth, and mystery. So next time you see the moon hanging like a lantern in the velvet dark, remember, it's not just decoration. It's a key player in Earth's story, a silent partner that has been shaping our planet's tides, time, climate, and maybe even life itself since the dawn of our solar system. It is a piece of our own world, flung into the heavens, forever bound to us in a cosmic dance.
Stay curious.